Hello and welcome back to my channel. This is part 23 of our Let's Get Cooking series, where we investigate cooking mechanics, kitchen mechanics. In the last 3 episodes we've been doing storage and removing and using items from bulk items. Today we're going to go back and do something a little bit different. At the moment we have a pretty boring menu. We've just got coffee and toast and bread and jam. So we're going to start making a new recipe. And what we're going to start with today is a sandwich, because the mechanics for this will also work in the next part of the series. Not the next video, but the next part of the series after we've done the sandwich. We'll introduce a burger grill and we'll start cooking some burgers. So today's work and the next few videos work will actually bring us in line ready for that. Okay, so without further ado, let's get going. To save a little bit of time, I've already imported the assets we're going to need for this, and they will be in the asset pack available to you for downloading. I've imported 2 cheese messes, a pack of cheese and a cheese slice, and a ham and a pack of ham. Now, so these are messes I've had made myself, so they're not necessarily that good, but if we got better ones, go ahead and use what you have. There's nothing that we haven't done before. The only thing I will run you over with is the ingredients and show you what ingredients go where. So for the pack of ham and pack of cheese, they're pretty well the same. We just have a ham label or cheese label, depending on which one you're doing. And the colour goes to base colour, the other goes to opacity mask, and this is set up to be a mask material. Very simple, that's all we need for that. Like I say, the cheese one is the same. I can find it. It's the same, it's just a different texture. Save those. The other materials we've made a cheese 1 and a cheese 2. Cheese 1 has the 2 textures that are in the pack, and cheese 2 just has a colour which I've picked basically from the cheese texture, because this is the size of the cheese. They're very simple materials. And we've also got a ham material somewhere. And the ham is just the 4 textures that are in the pack. Okay. I'll just quickly go through the meshes to show you what I've done. The materials. So let's go to our ingredients. Let's try cheese first. We're going to go to a cheese slice first. We're using cheese 1, which is your top and bottom, and empty, and cheese 2, which is this side. Now this one for some reason hasn't exported as well as I wanted it to, but it has exported reasonably well. So we're using cheese label for 1, M2 and M1, the cheese inside, and we're using our glass jar material from our jam jars for the clear packaging. And the ham, we're just using the ham material, just 1 material for our ham. And the pack of ham, we're using glass jar, ham and ham label in that order. Okay, so that saves a little bit of time you steady watching me do everything. I'm just going to go ahead and close these. We're going to do a little bit of work inside a few of our blueprints, so we'll be skipping around the blueprints a bit. I'm sorry about that. Not a lot I can do about it, unfortunately. So we're going to start with where most of the work's going to be done. We're going to open up our blueprint parent of ingredients, BPP ingredients. Okay, so first thing we're going to do is we're going to add a new part in here. So select your top level or your base mesh. Base mesh is probably better. We're going to add a scene component. Okay, and we're going to call this next ingredient spawn. And to that, we are going to add a box collision. And make sure that is a child of this, because this needs to move with this, because we will be moving our spawn point a little bit at a time. So initially we're 0, 0 on the spawn point. The box settings are, we're going to leave as default, because we will change that per ingredient or per type. Okay, so we have a few functions to make, because at the moment we've only got the construction script and give data. So we're going to add a few more functions. First one is going to be called add new ingredient. The next one is going to be called calculate offset. Next one is check if can continue. And the last one is, oh, I'll spell that right, okay. Select mesh. Let me just correct the spelling mistake in there. Put my keyboard a little bit closer so I can see what I'm doing. So let's, first of all, let's make sure there's no new interfaces. I don't think so. If there is, we'll make them as we go along. So let's start with select mesh. The select mesh has an input, and it's called actor to check. And that's going to be of the base class actor. We're going to come out of here and we're going to say give ingredient data asset message. And we're going to promote this to a local variable and call it L data asset. Okay, first of all, we're going to say get the static mesh, like so. Going to promote that to a local variable. We're going to call that L uncooked. Now this won't come into effect in this video, but it will when we do the burger. So let's just make the whole thing as it is. So we're going to grab our local data asset again, and we're going to get our cooked data asset, and we're going to get the mesh from that. So we're going to get mesh, like so. And again, we're going to promote that to a local variable, and we're going to call it L cooked, like so. Okay. We possibly need to add some things to add. Let me just check. I think we need to add some things to our interface. So let's open up our ingredients interface. So we've got them there, and then we can go ahead and set them. So we're not interface, ingredients and data asset. I'm just going to open the same one up in my other project so that I can double check. Okay, so let's just hide the inherited ones for now. So it saves confusion. Okay, the last one we stopped at was, okay, so we need an enum. We need to make an enum. Again, this is not for today's video, but it will come in effect. So let's make it now. And we're going to quickly make a blueprint enumeration. And we're going to call it E underscore cooking method. Because later on we will be introducing different cooking things. So let me just open that up also. Okay, and I've just added a few things in here. As always, I start with none. I'm going to add a few different cooking methods. Boil, fry, grill, toast. I think I would spell that there for a second. And bake. And again, we can add these at infinitum as we need more. So back to our ingredient asset, we're going to add two new variables. The first one is going to be a cooking method. And that's going to be our E underscore cooking method we just made. And one more should be cooked, question mark. And that's a bool or boolean. Okay, so we've done that now. We can go back to our DA ingredients. Sorry, back to our BPP ingredients. We're going to get our LDA local data asset in. And we're going to say should, get should be cooked. Okay, because it will actually determine on what mesh we're going to use. Do a branch from there. and we're going to add a return node. And the return node is of a static mesh. Just a standard static mesh object reference. We're going to call it mesh. So on the false, if it doesn't need to be cooked, we can just put in the uncooked mesh as the output. And there was another call to a BPI ingredient, but we'll add that next time. We're not going to bother adding that. So for true, we're going to return again with the cooked mesh. It's as simple as that. Later on we'll add it so that basically what I'm saving time on for now is if it's been, has it actually been cooked? We're going to check has it actually been cooked, and then it'll return whichever mesh. But for now, for today, we don't need to go any further than that. So that's the select mesh. The next one is very, very similar to this one actually. Check if can continue, which is a pure function. And just check if the other one was a pure function, I'm not sure. Yes, the previous function we just made is also a pure function, so make sure you make that a pure function. Select mesh is also a pure function. Okay, so check if can continue. Again, same input, actor to check. Of type actor. First what we're going to do is do an is valid check. Use one with a question mark. Revamp node through here. I'm going to do the give ingredient data asset again. I'm going to run that off the valid. Okay. We're going to have a return node, so let's add a return node, and it has a bool on it. It's called can continue. If it's not valid, obviously we can't continue, so there's no point continuing any further on that one. From here, we're going to get our should be cooked. So it's very similar to the last one. I'm going to do a branch. If it's false, it doesn't matter, we can continue. So let's copy and paste here. And we'll say yes to that. And again, the next one I went into more cooking stuff. So for now, we're just going to do this, and we'll change the way it can be cooked. We're going to change it later, because we're going to add some variables about has it been cooked, etc., etc. So that's that. We do need to add a couple of variables in here. which we will do. So we've got a number of applications. Has been cooked is here. Okay, so we're going to add one called stack. And I'll call it stack for want of a better name. I racked my brain and couldn't think of anything better. So this is going to be of an integer and my favorite map and of DA underscore ingredient. Okay. Next one is going to be called stack index. So basically the stack index is just a single integer. So basically what the stack is the layers in your recipe, whether it's a sandwich. In this case, we're going to make a ham cheese sandwich. So it's going to be your bread, your ham, or your bottom layer we're not counting because the bottom layer should always be there. And it's going to be your next layer, the order in which you want to put it. So in my case here, I'm going to put ham, cheese, and then your top bread. So there'll be 3 in the stack. But if you've got a burger and you've got different vegetables on it and different concoctions or 2 patties or whatever, then you can add to the stack. And we'll be adding that into our recipe data asset later. And I've got 2 here, and I'm going to put them in, but I'm not sure whether I've used them all because I've done some changes. Has been burnt, question mark. So it gives you an insight what's going to happen. Can we actually, and the other one is on board, question mark. So yeah, we are going to have the ability to burn food. So if it's burnt, obviously you don't want to be sending that out to the customer. So we would do checks for it here, and we would refuse that we can add it. So that's that one. Let's go back to our functions. Calculate offset. This is because we are going to be wanting to move the stack up a certain amount depending on what ingredient. We don't know what thickness the ingredient is going to be necessarily. So rather than hard code it, we're going to get it to actually use its own functions. Now, the biggest difference with that is bread, because bread is the only one, because of the way we use it in the toaster, where the pivot point or the message point is not in the center bottom. It's actually at one side on the bottom. So we have to allow for that as well. That's a little bit of hard coding going on there. So again, this is a pure function. We have an import of ingredient. And that is DA ingredient. So it's DA base. And we have an output of, we're just going to call it return value. And it's a vector, the location. So let's break these for a moment. And let's, first of all, do some tests. So we're going to say, is this equal to DA underscore bread? We're going to do a branch from there. We'll handle the bed first, so why not? So we're going to, let's move this out of the way. We're going to get ingredients. Right at the bottom here from the function, get ingredient from our function. So copy and paste that because we're going to use it twice. So we're going to get its mesh. And we're going to find out how big the mesh is. So we're going to say get bounds. Like so. We're going to split this pin. And you see we have 3 more pins here. I'm going to move this down because we're going to need a bit of space at the top here. And then we're going to go to the return value box index here. Box extent, sorry, not index. And we're going to split this pin. All we care about is the z-axis here, okay? We're going to add a local variable. In fact, what we can do is promote that to local variable and call it L offset. Going to be needed there anyway, so why not? We're going to get our L offset, we're going to set it. We're going to get our ingredients. And we're going to see, I don't know whether we've got this in here, I'm going to check. Spawn, no we haven't. So in our DA ingredients, thought we had it. Maybe it's an inherited variable, let me just check. Mesh scale. Ah, okay, so we need to go to our DA base, so click your little pen up here. Open up a DA space, we need to add a variable here and we're going to call this spawn offset. Actually rename that spawn offset location. Duplicate that, and we're going to call this from spawn offset rot for rotation. The location must be a vector, the rotation will be a rotator. Compile that, back to our DA ingredients, now you see them here, we should be able to get them. So back to our BPP ingredients, we're going to get spawn offset location here. We're going to right click this pin, split the pin. We're going to split this, so no we're not, we're going to make a vector, so make vector at the bottom here. Our X and our Y will be the same. And our Z will come from here. Okay. We will then set that. And set that to there. Now, if it's not, but it's quite simple, we're going to literally get this again. You can copy that, paste that. We're going to recombine the pin. We've got that. And we're going to get the box extent and we're going to divide it by 2. So we right click on this pin here, convert it to a float, and just say divide by 2. Because this is, we want to find where we want to move the item by that amount, well that's the full amount, so we want to move the item by that amount. And then we're going to get our local offset again, set it to the result of that. Let's move that out here. Let's move these back, make it look a little bit nicer. Okay. So that's that one done. Let's just neaten this up a little bit. Programmer's OCD, right, okay. So that's that one done. And now the final function we're going to do in this blueprint for now is add new ingredient. Now this has 2 inputs. First one is ingredient to add. And that's going to be an actual blueprint, so it's BPP underscore ingredient reference. And next one is spawn location. No, sorry. Spawn point, not the location. And that's going to be of type scene. Component, make sure you use a component, not any of the other scene ones. And it's going to have an output success. And that's a ball. So let's get going on here. First of all, we're going to do promote this to a local variable, save strings, call it L ingredient. I know we can call it from here, but also it helps with moving stuff around. We're going to get the kitchen manager. And we're going to say give ingredient for current stage. Okay. And we're going to promote that to local variable. We're going to go L ingredient name. Then we're going to get our local ingredient. We're going to get the item mesh. Oh, hang on, maybe just get, I think we called it base mesh in here. Get base mesh. Get bounds. Now we're going to say get component bounds this time. Get component bounds, this one here. We're going to break the box extent. We're going to promote this to a local variable. We're going to call it L up. So the offset calculates whether it's left, right, forward, back, and this one calculates how much we're going to move it up if we need to. We're going to get our ingredients again. I'm going to say give ingredients data asset. Like I say, if you're following the series, you should have all of these. We're going to promote that to local variable. We could call it LDA underscore ingredient. Like so. Okay, we're going to drag out of here and we're going to get ingredient type in here. And we're going to say, is this equal? Make sure you choose the equal enum to the local ingredient name. I'll probably be inclined to move these up a little bit. The branch. So let's handle the false first. So in the false, we're going to say add chef comment, and we're just going to say something like wrong ingredient, and then we're going to return as not successful, like so. Okay, so that's that one done. Next thing we're going to do is we're going to drag in the stack. We're going to find, and we're going to find the stack index. And just to be clear, we're going to set the default value of the stack index to 1 because we're starting from 1 rather than 0 in this. And we're going to say get that, and we're going to say is this equal to this, and we'll do another branch. So we're now checking, is it the right ingredient for the stack? Okay. This should take care of it, but in case it misses it, this will catch it as well. And we can just return unsuccessful on the false. It's not an ingredient stack. You could put a message in if you wanted to. So the true, what we're going to do for the true. So we're going to get spawn point. So we're going to say spawn point, like so. We're going to need a little bit of space for this, so put it down here. We're going to say add a local offset. Then we're going to get our calculate offset. Here. Let me make some more space. Plug that into there. The ingredient is our local DA ingredient. There. Don't check any of those. Then we're going to get this spawn point again, so we can reroute node across that. And we're going to say get relative transform. That one there. What we want. Okay. Then we're going to say add static mesh component. So what we're doing in here, we are not adding the actors. we're dropping the actors on it, and then we will, once it's successfully added it, we will then delete the actor, but we're going to leave a mesh. It's better performant, and it's also easier for when we're dealing with it later on, when moving it around, putting it in the food box, so on and so forth. It all becomes one. Then after that, we're going to say we're going to get our LA ingredient again, local ingredient again, but not the data asset with the blueprint. We're going to say, then we're going to get our select mesh, like so. We're going to then, from here, we're going to say, oh sorry, set static mesh. Because this just spawns a mesh, but it spawns an empty mesh. And that mesh is going to be this mesh that we've chosen from there. Good branch, make sure that's successful. Again, if it didn't spawn the mesh, there's something wrong, so we're going to return not successful. Then we are going to say, we're going to get our spawn point. And we're going to set relative location. And we're going to split the pin here. We're going to get our spawn point again. Copy and paste that. We're going to get relative location. Because we've already offset it left, right. Well, now we just need to make sure that we've got the up correct. So the X and the Y is fine. We just copy those. And we set this one called up a while ago. We're going to get this and we're going to add this amount to it. And that'll be the Z. So then we are going to destroy actor. And the actor is going to be ingredient to add from the function, that one there. Then we're going to get our stack index here, and we're going to increment it by 1. So we're now on stack index 2, so on and so forth. Get our Pixel Manager again. Then we're going to say set stage complete. And for now we're going to, we're going to now just return this. So return, and we're going to return that as success. Later on we'll be doing some more from here, but for now that's it. So that's our add ingredient. So let's see what else we have. What do I have in the event graph? I'm sure there is a lot. No, it isn't. I haven't done it in there. So I think the rest is called per blueprint. Yeah, I believe the rest is per blueprint. Okay, so there's one more thing we need to add. I was just sorry about the quiet there. I was just double checking. In our blueprint interfaces, in our BPI ingredients, under our ingredient or under our tab here, we've got a function called create stack. And that has an output called completed. It's a boolean. Okay, the others we're not going to worry about apart from one more. We're going to say set is on board. Okay, and the set is on board. This has an input. This is called is on board question mark. So let's go ahead and sort these out. So we're back to our BPP ingredients. Interface section. So let's do set is on board first. We've made the variable earlier, so we're going to use that. We're going to do a branch, and we're going to get the box, and we're going to say set collision to else. Set collision enabled. And you're going to want this twice. We'll copy and paste it. Make sure you join the target, or you'll get errors in compilation. If it's true, we're going to say query only, no physics collision. And in false, we're going to say no collision. Now, I'm also just going to check, I believe, yes. So let's move that down out of the way of that one for a moment. In our event graph still, right at the top of our begin play, after this one here, we can drag the box in, and we're going to say set collision enabled to no collision. We can turn the collision off on the box. We only want it to start colliding and doing things once it's actually on the board, when we're ready to actually add ingredients. We don't want it to be reacting and doing strange things, firing off events and giving lots of error messages and so on and so forth. So that's that one. And then next one we need to do is our create stack. You say get kitchen manager. Say give recipe, and we won't be able to actually continue this one because we need to go into our DA recipe and add the stack. So we need to go back to our data folder, here assets, DA recipe, and say it is going to be jumping around a little bit on different blueprints, but that's the way it is. But also you can, I hope you can appreciate that this system is fairly flexible. We can just by adding the odd variable here and there, we can change things around. So let me just hide inherited, like so. So we've got appliance type used already, and okay, yeah, we need to just add one more variable, and this is called ingredients stack, and it's of type integer. It's a map of DA ingredients. Like so. Okay, just make sure you compile and save that. Then we can go back to our BPP ingredients, to our create stack. And we're going to say get our ingredients stack, like so. We're literally going to drag in our stack variable that we made earlier. Of the ingredients into this. Why is that not? My mistake. I did it the wrong way around. No. Oh, I know. I've got ingredients list. Ingredients stack. That's why it didn't match. Okay. I thought I wasn't going crazy. We're going to then make sure we set our stack index to 1, just in case it didn't default back, just as a safety. And we're just going to return completed. And that's fine on that. Make sure there's nothing else we need to add. No, I believe that's all we need to add into here. Let me just see how we're doing for time. Okay, we've got 15 minutes, so I'm going to call this one here. I'm going to have a coffee break and then carry straight back on myself, and there'll be another video up shortly after this one. In the next video, we're actually going to be implementing it on the actual individual actor, in this case, a slice of bread. Thank you for watching. As always, don't forget to hit that like button, subscribe if you're not already subscribed, ring the bell for your notifications. I always forget to say that one. If you really like what I'm doing, you can join my Patreon or buy me a coffee. Any queries, any questions, you are welcome to join my Discord or ask me in the comments below. Thank you for watching. See you in the next one.